Okay, so now I have another example where you have to construct a confidence interval, but before you can do that, you have to calculate the mean and standard deviation. So what I'll have you do here in a minute is just pause the video, see if you can work through this whole problem yourself, and then when you think you got it, then go ahead and you can watch the video and see how you did. So in this case, this is the sample of products, so maybe a company that makes potato chips or something, and this is a sample for the weight in ounces for the product. Okay, so go ahead, pause the video, and see how you do. Okay, so let's go ahead and try this, and you can go ahead and check your work. Okay, so what I'm going to do is I'm going to clear everything on my calculator, and I'm going to use my calculator to find the sums. So I'm going to hit mode and hit 2, and now I'm going to put in 13.1 m plus 14.3 m plus 13.9 m plus 12.6 m plus 14.6 m plus 12.8 13.4 14.1 12.3 and 13.7. So there we go. We got all 10 values in there. Hit shift 1, 2, and what I get here for my sum of x, and I'll do this over here, my sum of x is 134.8, and now my sum of x squared is 1822.42, and my n is 10. I didn't need to do that, did I? Because I knew there were 10 values. Okay, so the mean here is 134.8 divided by 10. Okay, now remember the rounding rule and check your work on this to make sure you did this right. So these are all to the 10th place. So what you want to do is you want to round the mean and standard deviation to the 100th place. So you want 2 places after the decimal point. Okay, so dividing that by 10, I just move the decimal point over, right? And I get that the mean is 13.48 ounces. Okay, so now for the standard deviation, I take the sum of x squared minus the sum of x, that quantity squared, over 10. All of this over 10 minus 1. And then I take the square root of that. Okay, so 1822.42 minus 134.8 squared. Make sure you get the sum of x up here, not x bar. That's a common mistake that I see. So the sum of x, and then this is divided by 10. And so that's the top. Now I'm going to divide that by 9. So I'm going to divide by the bottom. That's the variance. Now I'm going to take the square root of the answer, and then that is the standard deviation. And I'm going to round that to 2 decimal places as well. So it'll be 0.77. Okay, so there is the mean and standard deviation. So now I'm going to construct a 99% confidence interval. Okay, so my degree of freedom here will be 10 minus 1, which is 9. So I've got 9 degrees of freedom. And now I want to go to 99% confidence, so that's this column, and I'm going to go down to 9 degrees of freedom, so I get 3.250. So my critical T value is 3.250. Okay, now I can construct my confidence interval. So the mean here is 13.48. Okay, my margin of error is going to be this critical T value, 3.250, times this standard deviation, 0.77, over the square root of n, square root of 10. So I'm going to place this in my calculator. So 3.250 times 0.77 divided by the square root of 10. Okay, and that's my margin of error. Now, I'm going to round that to 2 decimal places as well, okay, because the margin of error needs to match the mean and standard deviation. So I get 0.79. So this is 13.48 minus 0.79, 13.48 plus 0.79. So my lower endpoint is 12.69, and then my upper endpoint is 14.27. So I would be 99% confident that the true mean weight of the product lies in this interval. Okay, so that is confidence intervals for smaller sample size. And notice in this particular section, we don't worry about finding the sample size to get a desired level of precision, because usually when you look for the sample size, it's going to be bigger than 30 anyway, the sample size that you need to get your desired level of precision. And so in that case, it wouldn't be a small sample confidence interval. So we're basically just learning about the t-distribution, about the t-table, and about calculating the mean and standard deviation here on your own before constructing the interval.